proceed with the next presentation, which is a rail system model, Ontorail, which so is presented by Pierre Tane.
Thank you. Hello everybody, I'm Pierre Tane. I'm head of digital modeling at UIC. I'm also a contributor to the FRMCS project that was presented by Jean-Michel this morning. I'm also involved in European spectrum regulation for railways. But in the context of this presentation, I'm going to talk about two particular initiatives that UIC has launched to help digital continuity in railway system models, and with the ultimate goals to reduce cost and foster innovation. So we can go to okay. So, as we have seen from many presentations, the railway system is complex. For it to operate efficiently, it needs to be to operate as a whole, but nevertheless composed of many subparts. It's a complex system of systems, and as such, there has been various standardization efforts to represent and to model these various systems, such as signaling, infrastructure, telecom, and a few others. And next slide, please. And the challenge is that we already see we already have multiple models within the railway domain, but the railway domain doesn't exist as a standalone. It's part of the greater ecosystem. It's part of public transport as well, for which there are efforts in terms of modeling as well. And here, the icon is one of the transmodel from Sensenelec. That's one of those models. And the railway system is also part of a greater set of issues for society, such as environmental impacts of transport and things like this, for which all these initiatives have their own set of standardization for modeling purposes. So, next slide, please. The issue we're facing with this flourishing of various models is that on their own they actually simplify or help solve some business problem, but nevertheless they are still fragmented, and as such they lack digital continuity both across domains, as in if we want to move from one, if we have a system that is modeling one part of a domain and we want to use it to use some of its data for another subdomain, we usually need to do either model transformation or at worst to redigitize completely to actually be able to do these kind of studies. And there's also digital continuity, discontinuity across phases of the model, in the sense that for different stages of a railway project, we might also face difficulties reusing directly in a digital manner what has been done at the previous phases. And ultimately, this digital discontinuity is a source of cost because it takes time to do this transformation, and it's time and effort that are actually not useful to what the railways are trying to do. It's essentially wasted efforts. And last but not least, it's also a source of vendor lock-in, which itself is a source of cost, to the extent that if it's too painful to actually move objects from one phase to another or between domains, then sometimes it's easier to stay locked in one vendor environment, and that's something we'd like to prevent. So the Links 4 Rail project, which is part of the Shift to Rail initiative, that's something that they identified back in end of 2019, and that's where the kickoff of Links 4 Rail project took place. And here we see on this slide, which is what they had provided at that time, they identified this fragmentation of the landscape and the need to be able to interplay and interchange between various models. And that's where, next slide please, that's where the notion of the conceptual data model of Shift to Rail took place. And particularity here is it's viewed as a federation of models. As we know, there's a famous, or some of you might know, there's a famous KCD cartoon which says that when there are 14 competing standards and you want to unify them with a 15 model or standard, you end up with 15 competing standards. And that's what we want to prevent. And as such, that means that if we don't want to unify them into a new standard, then we need to federate them. And here federation is to say we interlink standards or models between each other where relevant, but they still retain their independence. And their independence allows them to evolve and so essentially to progress on the domain they are actually modeling, while still be able to be tied to the rest of the digital ecosystem through the digital continuity. And the spirit of what the CDM wants to do can be exemplified through 4 operative words. The first one is openness. Openness is about giving a model which has no barrier to use, and for which there is also no hidden vendor lock-in, such as certifications, for example, that would be mandatory to be able to use that model. It's also openness towards other other digital models, in the sense of the second slide that I presented, which is that if we use open standards, then we can actually link them to other digital models present and explore new problems. The second one is the federation, which I briefly glanced over already. So here, federation is about linking concepts between different models together, and it's about leaving each of the models that are federated their own independence of evolution in order to benefit from their evolution while still being able to tie them to the ecosystem. Third one, and that's related to this linking, we need strong semantics. And here, in the particularity of the CDM, we are exploring the use of ontologies as a formal representation of knowledge, and with the ultimate goal that first, it's formal in the sense that it's non-ambiguous how concepts between models relate to each other, but potentially more importantly, it's batch-in processable, which means that we can create new knowledge, amongst other things, from this formalization of the relationships between various models. And an additional point about semantics is that, and we are also already facing it as part of the convergence effort we're trying to do in the CDM, is that sometimes, even with the best intention, models can be a bit ambiguous as to what they are trying to cover, and it's very important to work on appropriate documentation of the models to facilitate or to prevent misinterpretation and ultimately limit future additional processing to correct this kind of errors. And the fourth one is related to the continuity across project lifecycle, and also across project dimensions or project domains. And so those 4 aspects are what the CDM is trying to address. And if we move to the next slide, please. So if we have that, that would allow us to move objects from the various phases without losing tracks of where they are coming from, and that can lead to be able to consistently track, link requirements to the way they are implemented in actual railway projects. And it's also the vertical movement between domains, which allow to take the knowledge from one domain to benefit it in a second domain. And that also would be desirable, but nevertheless, to actually get there, because we have this constellation of models, we need to identify what they have in common, where they overlap, because naturally, being independent, they might actually try to model the same thing on their own, and sometimes they have modeled it the same way, sometimes it's in a slightly different way, and that's one of the key area of work that will take place in Ontorail. And finally, there's also the need to identify a way when they have either commonality or they overlap to potentially identify new concepts by which we can link them that might be at a higher level of abstraction, but that ultimately would provide the bridge between those models. So next slide, please. And so that's where the 2 initiatives that UIC is working on are coming into play, and these are essentially 2 building blocks to establish this digital continuity between models. So the first one is RSM, Railway System Model, which is known to some as a rail topo model before. It's a generalist model in the sense that it provides high-level fundamental notions of railways, but it doesn't intend to model by itself the entirety of the railway. So the spirit of the RSM project is to work with more specialist projects that are doing specialist modeling, like U-Links for signaling, for example, or IFC Rail in the domain of BIM for railways. And to be able to provide this anchor and this backbone to these other more specialist models. A particularity as well is that it's built on the solid principles, and as such it's actually quite easy to extend, to introduce new notions. And one such project where it demonstrated it was rather easy to implement a new domain was in our collaboration with the Optima project of Gabriele, which we will hear about in some 15 or 20 minutes from now, where we introduce, for example, a weather package to address the needs of the Optima project. The second project or initiative of UIC is Ontorail, Onto for ontologies. And ultimately it's intended as an encyclopedia for railway knowledge. That's one thing. And also second thing, it's a tool to establish consensus as well. Next slide, please. So just a quick word on RSM. So when I was talking about fundamental notions for railways, so it's a successor of Rail Topo model, and as such topology was where it was coming from, to be able to describe in the topology of railway networks at various scales, at micro level, but also at much higher granularity. But also fundamental notions such as positioning or location around on a railway network, such as linear positioning, for example. As part of the collaboration with IFC Rail, the geometry of tracks, we've actually integrated the way they were describing geometry in the railway system model. And one particular item I wanted to highlight was that's new in the recent release of RSM. It's the specification, observation, and prediction package, which is intended to address, amongst others, predictive maintenance use cases by providing a generic abstraction about the various stages of something we might want to measure. That being said, as I briefly explained, we don't intend to reinvent what is already present, and as such, we are taking whatever open standards are already available and making them, adapting what they provide for railway purposes. And here, the first one that I listed here is the W3 SOSA SSN, which is for sensor networks. And that's at the heart of the description of the specification, observation, prediction package. But also standards like coming from OGC for positioning, for example, or even glyph ontology for description of companies and things like that. And finally, on a strong emphasis on collaboration, as I mentioned before, and I've listed two of the main partners of the RSM project, which are U-Links on the data prep for signaling, and IFC Rail for the BIM business. Next slide, please. And so for Ontorail, so it's a project in development, because RSM has been started back in 2016, so it has quite an history there, but Ontorail is actually from mid-2019 and is still in development, but we have a working prototype in place. And the idea is to consolidate at the ontology level the various knowledge of the railways models, and to be able to provide through ontologies the linking between the relevant concepts, and using ontologies again to provide this formal description of the knowledge, which we can then use, for example, to make new inferences about the railway system knowledge. The important thing as well is that because there's all these models, there's a consensus that we need to help building between domain model experts so that they are in agreement about the fact that the concepts are related in a certain manner, and that's one of the key features we had. So next slide, please. So in short, what Ontorail provides at the moment, it's an import mechanism for UML models in XML format into a knowledge graph. But also we support natively ontology import. One of the models we imported is the European Rail Agency RINF model for registry of for interoperability. And so we import them all into RDF knowledge graph. So I've listed on this slide the ones that are as part of Links4Rail imported: RSM, ULinks, AFC Rail, X2Rail4, and the RINF, as well as Transmodel. Transmodel was originally not considered, but thanks to ongoing work in Links4Rail, we actually also imported it. Next slide, please. Then, once we have all this knowledge in Ontorail, we provide unified searching and navigation inside the models. And there's also, so it's in the form of a tree view where we expose the various properties of the objects that are present in the models. And the second thing is a graph view to see objects in the context in which they appear in the models in which they are coming from, and also in relation to other concepts in other models that would have been established through the tool. Next slide, please. We are also able to do parallel browsing of these various models. That's to facilitate understanding the differences between concepts and build this consensus. Next slide, please. And then for the establishing the consensus, once we establish that two concepts are related, we have a working process through a forum that allows the model experts to agree on the relationship between those concepts, and ultimately to record it as a formal knowledge in the Ontorail knowledge base. Next slide, please. And finally, we can export that knowledge either as a federated to a Sparkle endpoint or as an export in an ontology format. Next slide, please. And finally, so what we were trying to do, that I explained before, was where RSM is coming into play. It's creating this anchor between concepts, and Ontorail is the tools that we are providing in order to identify the commonalities between concepts, between various models, heterogeneous models. And so far we are at the early stages of recording now some of the consensus between model experts that are involved in the Links4Rail projects. And with that, I'll conclude my presentation. Thanks for your attention.
Merci.